I like a freestanding deck, and most of the decks I build are freestanding primarily because I don't have to do any flashing work up against the house. And also, in most code jurisdictions, the footings themselves do not have to go to frost depth. You only need to be 1 foot below any excavated soil. So in this case, the owner wanted to get involved in the project, and one of the high labor cost of doing a deck is putting in the footing. So the owner took that project on. So I had him dig down just below the undisturbed soil, and then he formed the size of the footing based on the code that I suggested, as well as bringing the piers up to the surface. Then we see 4 other footings, these rectangles here, and those are set around the outside edge of where our wraparound stairs will go, and those were dug down to the undisturbed soil. So I ganged together the deck board several months ago just to get my dimensions for the deck design, but I wanted to double check it here. So here we're installing the Trex Hideaway hidden fasteners, just dry fit. I like using a system where the hidden fasteners are designed and intended for use with the decking that we're installing so that it is part of a system. And we're just dry fitting these so we can get that dimension from the house side of the deck to the outside face. So I've ganged together all of these hidden fasteners. I need 2 different dimensions. One is a dimension of 2 deck boards plus the airspace, which adds up to 11.5 inches, or a little bit less than 11.5. That's going to be the size of the 1-2 steps that we'll have reaching up to the top of the deck frame. The second dimension I want is the dimension from the house side of the deck boards out to the front. Now we're targeting roughly 5 feet for our deck. So I could do 1 of 2 things. I could dial it back and go with 57 inches for our finished deck depth from the inside of the house to the outside edge of the nosing of that last border board. Or I could bump it up to 62 3/4. And I talked with the homeowner about this, and we're going to go with a little bit proud of the 5 feet. So we're going to dimension everything at the 62 3/4 shy. From that measurement, now I can design the deck frame. I'm going to subtract an airspace at the back of the deck, and I'm going to subtract the nosing, the fascia board, and a little bit of an airspace behind the fascia board to the deck frame. Once I subtracted those, I have the deck frame dimension. So now that we got our deck dimensions, we're going to figure out where the anchor is going to go. So we marked out the story pole to match the center positions for all of our important points that were on the plans. So now we can snap the lines. Good? Okay, re-chalk. So we snap these chalk lines to be the back of the framing that's going to support the deck stairs. So I want to use a 2x to gauge the distance between the vine and the face of the concrete, because any portion of the concrete which is beyond the face of my 2x will need to be trimmed off with a grinder. And you can see here this whole portion of the footing, we'll have to chop it back, otherwise it will interfere with the homeowner's concrete paver patio that'll go in later. Instead of putting the anchors in during the pour when the concrete's still plastic, I like to drill the hole afterwards because that gives us much more control over precisely locating that hole. So the reason I blow out the holes is to keep that dust that's stuck on the side of the shaft from gumming up the bolt when it goes down into the hole. So this is a post base, and we need to anchor it to the footing. We're using expansion anchors, wedge anchors, that has a little collar on them and a flared bottom. So when we drop this in, it goes in kind of like a fish hook. As we're drawing it out, as we turn the nut, that collar will expand and press against the side of the hole and hold that fast to the footing. So we got the post bases in. The next thing we have to figure out is the height of the posts. So I made a story pole that references all the important points on the whole deck in vertical planes. Patio finish, top of the frame for the first step, top of the frame for the second step, top of the deck framing, top of the door threshold, which is where we established a height for all of our top of the deck, so when you step from inside the house down to the deck, it's not going to be too tall. And then we mark the bottom of the beam, which is going to be the top of the post. So what we're going to have Addison do now is I'm going to set the height of the laser receiver so that it registers to our reference point, and he can just draw right across here onto our post. That way we don't have to do any measuring and marking. We're doing it in one step, so we have a lot more accuracy going direct from the story pole right to the post. That line is going to be the top of the post, which is analogous to the bottom of the beam. Now I've got 3 other blocks there. Let's do each one separately. So we're ready to start putting the posts in, but before we can do that, we have to coat all of the cut ends of the posts, as well as later on all of the joists and beams with copper naphthenate. This is a code requirement that's been in the code for at least the last 20 years that I know of. And you're supposed to coat it to the point where it accepts no more of the solution. That means that it could be 1 brush over, or it could be 2 or 3 or 4 brush over. So we usually put it on and then let it sit. We could just put the post in and nail it in place. The coating is good enough to be in contact with the pressure treated lumber, but an extra step you can take, which will improve the longevity of the hardware, is to put an isolation membrane between the pressure treated lumber and the metal hardware. And this would be for the post bases, post caps, joist hangers, and tie down clips. Anything where you've got metal hardware touching the pressure treated lumber. So the isolation membrane I'm using is nothing more than the flashing tape that Trex has for putting over the tops of joists and beams. This is their 4-inch tape. So we got the beams cut to length. They're the same length as the deck that the joists will rest on. And I got to nail it together. And there's a pattern that the code dictates. We need a row across the top and a row across the bottom. The row across the top, 16 inches on center. Row across the bottom, 16 on center, and then staggered. So we're going to do an up-down pattern that are offset by 8 inches. And we're going to use a minimum of a 3-inch long galvanized nail. Yeah, like that. So that'll orient which way you're going to put the tape. And then when you put it on top, put it dead center. Because the 3-inch beam could be flush to the back or flush to the front, but we'll put it dead center. So we use nails to nail on the post bases, and we're using connector screws to attach the post caps. And they are interchangeable, they work fine. So I'm using another piece of the Trex flashing tape as isolation membrane. Because it's hard to position the tape on the beam, because we'll be setting the beam and shifting it back and forth, I'm going to apply the tape to the hardware first. It's not as easy to apply it to the hardware first, but in this instance it makes more sense for us. It's like dead flat. We never get that. Okay. To me. So what I'm doing here is I cut some 1-inch blocks to use as spacers. All of our deck framing is going to be spaced 1 inch off of this skirt board. So just have a bunch of spacers that space the beam, the space the joist, and space the rim board on the inside. That way the water can flow through that gets underneath the decking. That side looks fine too. Let me set the spacer block in first and drop my end before you drop yours. Okay, you can go down. So this is the Trex beam tape. They also have a joist tape, which is about 1 5/8 inches. This is about 3 1/8 inches. And it's made to cap over the top of a double 2x beam. So the reason we put the flashing tape on top of the joists and the beams is it's going to extend the life of the deck. You don't think about the pressure treated wood as being vulnerable to decay and But it is, and the more we can keep water from getting into the middle of the wood, the longer it's going to last. So this deck could last 50 or more years easily with these extra steps we're taking.